Welcome to Section 9, Lesson 2. Once a rational expression is simplified, the next operation to learn is multiplication and division. Both work the same way they do for numerical fractions, with one twist: factor everything before cancelling. Multiplying rational expressions is a single step. After factoring, cancel any factor shared between any numerator and any denominator, then multiply what remains. The result is one rational expression, often in a simpler form than either original. Dividing is one keystroke different. Keep the first expression, change division to multiplication, flip the second expression. After that, proceed exactly as you would for multiplication: factor, cancel, multiply. The procedure does not change. Domain restrictions accumulate as you go. Every denominator that appeared anywhere in the work must be excluded from the domain, even if it cancelled. This is the same idea as Section 9, Lesson 1, applied to two expressions at once. Take x squared minus 1 over x plus 3 multiplied by x plus 3 over x minus 1. Two rational expressions, one multiplication. The plan is to factor, cancel, then multiply what remains. Factor the numerator x squared minus 1 as x plus 1 times x minus 1. The denominators are already factored. Now the expression has four binomials and four binomials, two on each side of the multiplication. Cancel the shared factors. The factor x plus 3 appears once in a numerator and once in a denominator. It cancels. The factor x minus 1 appears once in a numerator and once in a denominator. It cancels. After two cancellations, only x plus 1 survives in the numerator. The simplified product is just x plus 1. Two rational expressions multiplied together collapsed into a single linear binomial. Notice how factoring before multiplying made all the cancellations visible in one pass. Example 1. Multiply x squared plus 5x plus 6 over x squared minus 4 by x minus 2 over x plus 2. Three of the four pieces are factorable trinomials or differences of squares. The numerator of the first fraction x squared plus 5x plus 6 equals x plus 2 times x plus 3. The denominator of the first fraction x squared minus 4 equals x plus 2 times x minus 2. The second fraction's numerator and denominator are already in factored form. Cancel shared factors across the two rational expressions. The factor x plus 2 appears in both a numerator and a denominator on the first fraction, and again across the two fractions. Cancel twice. The factor x minus 2 appears in the first denominator and the second numerator. Cancel once. Multiply what remains. The numerator has x plus 3 left over. The denominator has x plus 2 left over. The simplified product is x plus 3 over x plus 2. Two rational expressions reduced to a single, simpler one. Divide x squared minus 9 over x plus 1 by x minus 3 over x squared minus 1. Division is the only operation that needs an extra preliminary step. Keep, change, flip. Keep the first expression unchanged. Change the division sign to multiplication. Flip the second expression upside down. The problem becomes x squared minus 9 over x plus 1 multiplied by x squared minus 1 over x minus 3. Now it is a multiplication problem and the rest of the procedure applies. Factor everything. X squared minus 9 equals x plus 3 times x minus 3. X squared minus 1 equals x plus 1 times x minus 1. The other two pieces, x plus 1 and x minus 3, are already linear factors. Cancel and multiply. The factor x minus 3 appears once in a numerator and once in a denominator. Cancel. The factor x plus 1 appears once in a numerator and once in a denominator. Cancel. What remains in the numerator is x plus 3 times x minus 1, and the denominator becomes 1. The simplified result is the binomial product x plus 3 times x minus 1. Three takeaways for multiplying and dividing rational expressions. They lift directly from numerical fractions, with the addition of factoring as a prerequisite step. Multiplying. Factor every numerator and every denominator first. Cancel any shared factor regardless of which fraction it sits in. Multiply the remaining numerators and the remaining denominators to write the final answer. Skipping the factor step leads to errors and unnecessary effort. Dividing. Keep the first expression, change the operation to multiplication, flip the second expression upside down. The keep change flip step takes 1 second. After that, the work is identical to a multiplication problem: factor, cancel, multiply. Domain restrictions. Every denominator that appeared anywhere in the work, including the one that became a numerator after flipping in a division, must be tracked. Any value of x that makes any of those denominators 0 is forbidden in the final answer.